Look at the skyline of any modern metropolis, and you are looking at the triumph of steel. The skyscrapers of the 20th century were only made possible by the steel skeleton, a flexible, high-tensile core that carries the crushing, catastrophic weight of the building above. Now, look at this photograph. Colossal stone facades, massive archways, a towering spire reaching 548 feet into the sky. What if I told you that one of the most massive, imposing, and structurally complex buildings in North America has no steel frame in its main body at all? History asks us to believe that men in the 1870s built a structure taller than the Great Pyramid of Giza using nothing but stacked masonry, horses, and localized steam engines. Today, we audit Philadelphia City Hall. First, the hydrological nightmare of the excavation and the 22-foot solid granite foundation. Next, the spatial and chemical paradox of laying 88 million bricks and the kinetic danger of hoisting pre-carved megalithic sculptures. Finally, we expose the iron spire anomaly and the aerodynamic impossibility of the 500-foot bronze hoist. You are watching Titan Metrics. The file is unlocked.
Official history states that construction on Philadelphia City Hall began in 1871, and the exterior was largely completed by 1894. We are told that architects and laborers used hand tools and horse-drawn carts to flawlessly assemble 88 million bricks and thousands of tons of solid granite and marble. The main body of this building rests entirely on its own weight. No structural steel, no reinforced concrete core, no modern load distribution software, just gravity and stone. Let us start with Chapter 1, the foundation and the flood. To support a towering masonry shaft of this unprecedented scale, the engineers of 1871 had to excavate a pit covering 4.5 acres right in the middle of a bustling, congested city. But Philadelphia is nestled between the Delaware and Schuylkill rivers. The water table is absolute. When you excavate a massive 4.5-acre crater in a river city, it does not remain dry. It instantly becomes a bathtub. Millions of gallons of pressurized groundwater actively bleed into the excavation site. To keep the workers from drowning in the mud, the site must be pumped constantly, 24 hours a day. In 1871, they had to rely on heavy, coal-fired steam pumps. If the steam pressure drops, if a cast iron gear fractures, if the coal supply is delayed by muddy roads, the pumps stop, the pit floods, the foundation walls collapse inward. You are fighting the subterranean hydrology of two rivers using 19th century steam power. And within this muddy, flooded crater, they had to lay the base. The foundation walls of the Philadelphia City Hall are 22 feet thick. Let us pause and analyze that raw volume. 22 feet of solid, interlocking granite blocks. That is the length of a modern heavy-duty delivery truck, manifested purely in the thickness of a single stone wall. In modern construction, creating a foundation this massive requires laser leveling, continuous deep-drilled concrete caissons, and computer-aided subterranean stress distribution models. Mainstream historians will point to the archives and claim that John MacArthur Jr., the lead architect, calculated the exact uniform settling of millions of tons of stone using nothing but paper, pencils, and 19th century surveying equipment. But historians routinely ignore soil mechanics. The ground beneath Philadelphia is not solid, unbroken bedrock near the surface. It is largely composed of clay, loose gravel, and sand. It is a highly compressible, unpredictable geological matrix. If an unreinforced masonry building of this unimaginable colossal weight settles evenly by even a fraction of an inch, the entire structure experiences catastrophic shear stress. The rigid mortar snaps, the 22 feet granite blocks violently fracture under asymmetrical pressure. The tower falls. You cannot dynamically balance millions of tons of dead weight on soft clay using primitive trenching and wooden plumb bobs.
If the geological foundation contradicts logic, the exterior supply chain entirely contradicts the transportation limits of the era. The exterior of Philadelphia City Hall is not just local brick. It is clad in hundreds of thousands of tons of white marble, limestone, and granite.
The official ledgers proudly state that the white marble was sourced from quarries in Lee, Massachusetts. The granite came from Maine and other distant states. Engineering defenders will quickly point out that Philadelphia was a major railway hub in the 1870s. They will argue that steam locomotives simply brought the stone directly to the city. Let us run a preventive strike on that exact alibi. We do not deny the existence of trains. We audit the transfer points. A 19th century freight train can bring the marble to a Philadelphia rail yard, but the rail yard is not the construction site. City Hall sits precisely in the center of Penn Square, at the intersection of Broad and Market Streets. You must physically move hundreds of thousands of tons of stone from the train cars to the center of the city. There were no diesel flatbed trucks. Every single multi-ton block of Massachusetts marble and Maine granite had to manually hoist it off a rail car, lowered onto a heavy-duty wooden wagon, and pulled by a team of draft horses through the densely packed, chaotic, unpaved streets of 1870s Philadelphia. A standard horse-drawn dray can safely pull maybe 2 or 3 tons of dead weight. To move the sheer volume of stone required to clad a 4.5-acre megastructure, you are looking at hundreds of thousands of individual wagon trips. The streets surrounding Penn Square would be entirely gridlocked. The physical destruction of the muddy roads under the constant grinding weight of iron-rimmed wagon wheels would render the streets impassable within weeks. The rail network is irrelevant if the final mile is a biological and logistical bottleneck.
And yet, the marble and granite are just the decorative skin. Let us look strictly at the internal load-bearing structure. The official record states that Philadelphia City Hall contains 88 million bricks. This is where the mainstream historical narrative expects us to stop asking questions. They throw out a massive number and expect the public to accept it as a marvel of Victorian grit. But here at the audit desk, we run the numbers. Let us assume a 30-year construction period from 1871 to 1901. Let us give the official ledgers the absolute maximum benefit of the doubt. We will assume they worked 365 days a year, with no stops for freezing Pennsylvania winters, heavy rain, labor strikes, or material shortages. We will assume a grueling 10-hour daylight workday. 88 million bricks divided by 30 years is roughly 2.93 million bricks a year. Divide that by 365 days. That is 8,000 bricks every single day. That means 800 bricks had to be flawlessly laid, mortared, and leveled every single hour. That is 13 bricks every minute, relentlessly, for 30 years straight.
And remember, these are not bricks being laid on a flat, simple sidewalk. These are bricks being hauled hundreds of feet into the air, assembled into complex, load-bearing vaulted ceilings, intricate internal archways, and massive structural supports. Mainstream historians will argue that contractors simply hired thousands of laborers and masons to work simultaneously. But logistics is not constrained by how many men you can hire. Logistics is constrained by spatial geometry and chemical reality. Let us audit the spatial bottleneck. You cannot physically fit thousands of masons, their complex wooden scaffolding, their mortar troughs, and a continuous supply chain of 8,000 bricks a day into a highly congested vertical workspace. The more men you pack onto a masonry wall, the slower the work progresses. You have horse-drawn carts trying to bring fresh heavy mortar in, while empty carts are trying to get out. It is an absolute, unavoidable traffic jam. But the ultimate impossibility is not spatial, it is chemical. Forensic engineers understand a critical concept called compression curing. When you build a towering, load-bearing wall out of wet mortar and brick, you cannot simply stack it continuously at top speed. If you lay bricks at a rate of 13 bricks a minute, rapidly building vertically, the mortar at the bottom of the wall has not had the chemical time to dehydrate, cure, and harden. The immense accumulating dead weight of the wet bricks above will physically crush and squeeze the soft mortar right out of the bottom joints. The wall will bleed mortar, lose its geometric level, and collapse under its own weight.
To prevent compression failure in massive masonry structures, you must lay a few courses, stop, and let the mortar cure. You cannot cheat the chemical dehydration of hydraulic cement and lime. The official timeline of 88 million bricks fundamentally ignores the non-negotiable chemical curing limits of 19th century masonry. To maintain that speed, you do not just need infinite masons, you need magic mortar.
If the internal bricks defy chemistry, the exterior sculptures defy all logistical kinetics. Philadelphia City Hall is covered in over 250 massive, intricate, highly detailed marble and granite sculptures designed by Alexander Milne Calder. Look closely at the archival photographs. Look at the level of anatomical detail. Look at how these colossal allegorical figures are flawlessly integrated directly into the load-bearing stone of the building. Mainstream historians will aggressively point out that these statues were not carved on the building. They were carved in workshops on the ground and then hoisted into place. Exactly. And that is what makes it a kinetic impossibility. We are not debating the talent of the sculptures. We are auditing the hoisting mechanism. To lift a beautifully carved, incredibly fragile, multi-ton marble angel or gargoyle 50 to 200 feet into the air requires flawless, smooth vertical logistics. In the 1880s, they did not have computer-controlled hydraulic tower cranes. They had steam-powered donkey engines and early wire ropes designed by John Roebling. Steam engines do not possess fine hydraulic control. A steam winch lifts through the raw, violent kinetic energy of expanding steam pushing a piston, which turns cast iron gears. It jerks. It stutters. When you suspend a 5-ton, highly detailed marble sculpture on a steel cable, and the steam engine jerks the load, the kinetic shock travels straight down the wire. The marble swings. If that multi-ton piece of delicate art bumps into the stone facade on its way up, the wings snap off. The face shatters, the block is ruined, and must be entirely recarved from scratch. You cannot dynamically hoist 250 megalithic fragile masterpieces using jerking steam winches in the unpredictable winds of Philadelphia without a massive documented trail of shattered art. Yet the official ledgers record a sterile, flawless assembly. The aesthetic perfection of the exterior completely contradicts the violent, rushed, hyper-industrial kinetics required to assemble it.
But if the brickwork defies chemistry and the sculptures defy kinetic shock, the crowning achievement of the tower defies raw aerodynamic physics. The main tower of Philadelphia City Hall reaches 548 feet, but here the official narrative is forced to make a stunning admission. At approximately 337 feet, the solid brick and stone masonry suddenly stops. The top 200 feet of the tower, including the dome and the spire, are not stone. They are a skeletal framework of cast and wrought iron, clad in copper and metal panels. Why? Because the math caught up with them. Even the most arrogant 19th century engineers realized that if they continued stacking stone to 500 feet, the catastrophic dead weight would obliterate the 22-foot granite foundation. The building was already cracking under its own mass, so they switched to an iron skeleton. But this admission does not save the official narrative. It only creates a new, terrifying aerodynamic anomaly. Atop this iron spire stands the colossal bronze statue of William Penn. It is 37 feet tall. It weighs 54,000 pounds. That is 27 tons of hollow dead weight. According to the official timeline, the statue was cast at the Tacony Iron and Metal Works. It was cast in 14 separate sections, assembled temporarily in the courtyard in 1894, and then dismantled and hoisted to the very top of the iron spire. Stop and visualize the terrifying engineering required here. It is 1894. There are no modern stabilization thrusters. There are no heavy-lift helicopters. There are no high-tensile steel stabilizing guide wires capable of anchoring a load at 500 feet. Engineering defenders will state that the statue was lifted in pieces, not as a single 27-ton unit. They will claim that primitive steam pulleys were more than capable of lifting a 3-ton bronze arm or a 4-ton bronze torso. But the defenders are completely ignoring aerodynamics.
Lifting 3 tons of compact iron is one thing.
Lifting a 3-ton, highly asymmetrical, hollow bronze shell, like a giant hat or a massive flowing coat, is something entirely different. At an altitude of 500 feet, the atmospheric wind shear in Philadelphia is brutal and unpredictable. The massive, irregularly shaped bronze sections of the statue would act exactly like giant metallic sails. Have you ever seen a 3-ton piece of hollow bronze catch a 40-mile-per-hour gust of wind? The kinetic pendulum effect is catastrophic. If a massive bronze panel catches a crosswind during the 500-foot vertical ascent, it begins to swing violently. The kinetic shock travels straight down the wire ropes into the hoisting gantry. A crane, perched precariously on top of an iron skeleton, cannot absorb the violent snapping kinetic energy of a swinging 3-ton pendulum. The rigging snaps, the crane splinters, and the massive bronze section slams directly into the side of the spire, shattering the iron framework and sending thousands of pounds of lethal debris plummeting into the courtyard below. Yet the official ledgers record an absolute flawless victory. Mainstream historians claim they just used pulleys and steam power and carefully bolted it together in the sky. But engineering is not a fairy tale. You cannot simply say the word pulleys and make 27 tons of asymmetrical bronze float 500 feet into the sky without addressing the aerodynamic nightmare. The sheer tensile strength required for the stabilizing rigging, the brutal exposure to high-altitude winds. The mathematics of the vertical lift are dangerously, completely missing from the official record.
And this brings us to the final piece of the puzzle, the financial ledger. A megastructure of this scale leaves a paper trail. The original budget for Philadelphia City Hall was estimated at roughly $10 million. By the time it was officially completed in 1901, 30 years later, the cost had ballooned to over $24 million. In today's money, accounting for inflation and the sheer scale of materials, that is the equivalent of multiple billions of dollars. It is a financial black hole. Mainstream historians dismiss this as classic political corruption. They claim the local political machine, the infamous Public Building Commission, simply embezzled the money over 3 decades through inflated contracts and phantom labor costs. But what if the corruption is just the cover story? When the mathematical logistics of the brickwork, the stone hauling, and the statue hoisting absolutely require a massive off-the-books shadow operation, you need a way to pay for it. You need to explain where millions of dollars are going when the official timeline clearly shows that 88 million bricks cannot be laid that fast by the official workforce. The corruption alibi is the perfect way to mask the catastrophic overruns of trying to reverse engineer, retrofit, or excavate a structure that was fundamentally breaking the limits of 19th century technology.
History asks us to accept a sanitized romantic ledger, but common sense logic requires physical evidence. When you audit the Philadelphia City Hall, the official story requires you to suspend your knowledge of physics, logistics, chemistry, aerodynamics, and human endurance. They want you to believe that men with hand tools flawlessly calculated the settling of a 22-foot solid granite base on soft, highly compressible soil. They want you to believe that 88 million bricks were laid, mortared, and perfectly cured at a frantic pace that modern robotics would struggle to match. They want you to believe that master artisans hoisted hundreds of megalithic fragile sculptures via jerking steam winches without shattering them. And they want you to believe that 27 tons of hollow bronze were hoisted 500 feet into unpredictable atmospheric wind shear without modern stabilization technology. At a certain point, it stops being history and it starts being an insult to engineering. The flawless, sterile reports hide a massive, undocumented truth. The mathematics prove the laborers of 1871 did not build this impossible megastructure using the simple, sanitized methods described in the textbooks. They simply did not have the chemical Turing time, the spatial geometry, or the aerodynamic technology. Which leaves us with the ultimate silent implication. If human biology and primitive steam hoists could not mathematically execute this timeline, what exactly did John MacArthur Jr. excavate, assemble, and retrofit in the center of Philadelphia? We are not looking at a standard 19th century construction project. We are looking at a mathematical fiction.
The forensic audit of the math proves that perfect construction reports do not exist. There are only well-hidden anomalies buried under 88 million bricks. But if you think hoisting massive bronze over a city defies aerodynamics, you haven't looked at what they assembled in the mud of New York Harbor just a few years later. Mainstream history claims that in 1886, a monumental 225-ton copper and iron structure was assembled on a muddy island using nothing but wooden scaffolding, hemp ropes, and primitive hand tools. They ask us to believe they battled the ferocious freezing winds of the Atlantic Ocean to bolt together an iron colossus without a single modern crane. The forensic audit of the Statue of Liberty and the Colossus fraud is opening on your screen right now. The investigation continues.